If you're about to go to sleep right now, wait for just 1 second. Because the thing you are about to do is something science still cannot fully explain. Every night, humans shut down their consciousness for several hours. We fall asleep. But the real question is, why do we sleep at all? Because nature created a system where every living creature, every single night, becomes completely vulnerable in front of predators, dangers, and the darkness. And yet, almost every creature on Earth sleeps. And that's not all. We also dream. We enter worlds that don't actually exist, but somehow feel completely real. Tonight, we will step into mysteries like these, questions that science has explored but still hasn't fully answered. And maybe, as these mysteries slowly unfold, your mind will begin to relax, and your sleep will grow deeper and deeper. There is something strangely calming about realizing that the universe still holds questions no one has answered yet. In a world that often feels rushed and crowded with information, it can be peaceful to remember that even the most brilliant scientists on Earth are still searching, still wondering, still standing quietly in front of mysteries that refuse to fully reveal themselves. Tonight, we are not chasing answers. There is no need for urgency here. Instead, we are simply going to wander slowly through a landscape of questions. Think of it like a quiet evening walk along a shoreline where the waves arrive one after another, gentle and patient, each one carrying a small piece of the unknown. For centuries, humans have tried to understand the world around them. We built telescopes to look at distant galaxies. We created microscopes to explore the tiny architecture of life. We developed powerful machines that can detect particles smaller than atoms and instruments that can listen to signals traveling across billions of light years. And yet, despite all of this effort, despite the enormous knowledge humanity has gathered, the universe still keeps many of its secrets. Some mysteries are enormous, stretching across the vastness of space. Others exist quietly inside our own minds. Some appear in the sky during storms, or deep beneath the oceans, or inside the strange behavior of particles that refuse to follow the rules we once believed were absolute. But perhaps the most curious mystery of all is something you are doing right now. You are aware. You know that you are here in this moment, listening, breathing, slowly settling into the quiet rhythm of the night. That simple awareness may feel completely ordinary, but when scientists look closely at it, they encounter a puzzle that no theory has fully solved. The human brain contains roughly 86 billion neurons. These tiny cells communicate through electrical signals, forming networks of astonishing complexity. Every thought, every memory, every emotion appears to be connected to patterns of activity moving through this vast neural landscape. But here is the mystery. Even if we map every neuron and track every signal, we still cannot explain how those signals become experience. Why does seeing a color feel like something? Why does music stir emotion deep in the chest? Why does the mind contain an inner world at all? This question is sometimes called the deepest puzzle in science, because even with all our technology and knowledge, the bridge between physical matter and conscious experience remains hidden. And perhaps there is something quietly comforting about that. The universe is not fully solved, not yet. There are still doors waiting to be opened, still questions resting gently in the dark like lanterns floating on calm water. And as the night continues, we will move slowly toward another mystery, one that touches every living creature on Earth, something so familiar that we rarely stop to think about it. Sleep. Sleep is one of the most ordinary things in human life, and at the same time, one of the most mysterious. Every night, across every continent, billions of people slowly close their eyes and drift into a state where awareness fades and the body becomes quiet. Streets grow silent, lights turn off in windows, and entire cities settle into the strange rhythm of rest. It feels completely natural, so natural, in fact, that most of us rarely question it. But if you pause for a moment and look at sleep from the perspective of biology, it begins to seem almost unbelievable. For several hours each day, animals willingly become vulnerable. Their senses dull, their reactions slow, and their awareness disappears almost entirely. In the wild, this would seem like a dangerous design. A sleeping animal cannot easily defend itself or run from threats. And yet, sleep exists almost everywhere in the living world. Birds sleep, mammals sleep, reptiles sleep. Even creatures with extremely simple nervous systems appear to enter rest states that resemble sleep in surprising ways. Dolphins sleep with only half of their brain at a time. Some birds can rest while gliding through the air. Even tiny fruit flies experience cycles that look remarkably similar to sleeping and waking. This raises a simple question that scientists have been asking for decades. Why? Why would evolution preserve something that makes living creatures temporarily helpless? Researchers have discovered many things that happen during sleep. The brain appears to perform important maintenance. Certain cells shrink slightly, allowing fluid to flow more easily through brain tissue, washing away waste products that accumulate during waking hours. Memories are also reorganized during sleep. Experiences of the day may be replayed by networks of neurons, strengthening important connections and quietly discarding others. In this way, sleep seems to help transform the chaos of daily life into lasting memory. The immune system also becomes active during rest, repairing tissues and strengthening the body's defenses. But here is the interesting part. Even though scientists understand many of these functions, none of them fully explains why sleep evolved in the first place. It may serve multiple purposes at once, or it may be connected to deeper biological processes we have not yet discovered. In fact, sleep is so essential that animals deprived of it for long periods eventually become severely ill. Their bodies begin to fail in ways researchers still struggle to understand. And yet, the original reason for sleep, the ancient evolutionary story behind why living creatures must regularly enter this strange state of vulnerability, remains unsolved. So tonight, as you rest and allow your mind to drift, you are participating in something that every living species shares, a behavior older than trees, older than bones, older perhaps than complex brains themselves. A quiet biological ritual repeated across millions of years. And within that darkness of sleep, another mystery waits. Because once the body rests, the mind begins to dream. Once sleep takes hold and the body settles into stillness, the mind begins to move in a very different way. Somewhere in the quiet activity of the brain, images appear, places unfold, conversations begin. Entire scenes take shape without effort, as if the mind has quietly opened a door into another world. This is the strange territory of dreams. Most people experience several dreams every night, although many of them vanish before morning arrives. A dream might last only a few seconds, or it might stretch across what feels like long moments of story and emotion. In dreams, familiar places may appear in unfamiliar ways. A childhood home might have extra rooms that never existed. A conversation may happen with someone who is no longer alive. Time itself behaves strangely, stretching and folding in ways that feel natural while the dream is happening. What makes dreams so mysterious is not simply their vividness, but the fact that science still does not fully understand why they happen. Researchers have learned a great deal about when dreaming occurs. Many dreams appear during a stage of sleep known as REM, or rapid eye movement sleep. During this period, the brain becomes surprisingly active, almost as active as it is during waking life. Electrical patterns flicker across neural networks, and the eyes move rapidly beneath closed eyelids, as if following the scenes unfolding inside the mind. At the same time, the body enters a temporary state of paralysis. Muscles relax so deeply that movement becomes nearly impossible. This prevents the body from physically acting out the dream, a safety mechanism that allows the mind to wander freely while the body remains still. But knowing when dreams occur is not the same as understanding why. Some scientists believe dreams help the brain process emotions. Experiences of the day, especially those connected to fear, stress, or uncertainty, may be gently reorganized during dreaming, allowing the mind to integrate them in a safer environment. Another theory suggests that dreams function like simulations. In this view, the brain is quietly rehearsing possible situations, practicing responses to challenges the body might face in waking life. Other researchers argue that dreams may simply be a side effect of neural activity during sleep. The brain may be generating random patterns of signals, and the mind, always searching for meaning, turns those signals into stories. Yet none of these explanations fully captures the strange richness of dream experience. Dreams can feel deeply emotional, sometimes even more intense than waking life. They can contain colors, sounds, sensations, and narratives that seem almost perfectly constructed, even though the dreaming mind is not consciously directing them. For thousands of years, people have tried to interpret dreams. Ancient cultures believed they carried messages from gods or spirits. Philosophers wondered whether dreams revealed hidden parts of the mind. Even now, with modern neuroscience and brain imaging technology, the dreaming mind remains one of the most beautiful and mysterious landscapes in human experience. And beyond dreams lies an even deeper question, a mystery that sits quietly behind every thought, every feeling, every dream itself: the mystery of consciousness. If dreams are mysterious, then consciousness is even more so. In fact, many scientists and philosophers believe it may be the deepest mystery in all of human knowledge. Right now, as you listen, there is something it feels like to be you, an inner sense of presence, an awareness that quietly observes thoughts, sounds, and sensations. You can notice your breathing, the comfort of a blanket, or the slow rhythm of the night around you. This simple fact, the feeling of experience itself, is what we call consciousness. At first glance, it may not seem mysterious at all. After all, consciousness is the most familiar thing in our lives. It is present in every moment we are awake. Yet, when scientists attempt to explain it, they encounter a question that has proven surprisingly difficult to answer. The human brain is an incredibly complex structure. It contains roughly 86 billion neurons, each one forming thousands of connections with other neurons. Electrical signals move through these networks constantly, creating patterns of activity that shift and change from moment to moment. Modern brain scanners can observe some of these patterns. Researchers can see which regions of the brain become active when someone remembers a childhood event, listens to music, or solves a puzzle. Over time, neuroscience has mapped many of these relationships between brain activity and behavior. But here is the puzzle. Even if we understand every signal in the brain, even if we map every neuron and every connection, there is still a gap between those physical processes and the experience they produce. Why should electrical activity inside cells create the feeling of seeing color, hearing music, or tasting food? Why does a particular arrangement of neurons produce joy, sadness, curiosity, or wonder? And perhaps the most puzzling question of all, why does experience exist at all? Some philosophers call this the hard problem of consciousness. It asks not only how the brain processes information, but why those processes are accompanied by an inner world of sensations and feelings. Different ideas have been proposed. Some scientists believe consciousness emerges from the complexity of neural networks once they reach a certain level of organization. Others think it may arise from specific patterns of information flowing through the brain. There are even theories suggesting that consciousness may be a fundamental aspect of reality itself, something woven deeply into the structure of the universe. At the moment, none of these explanations has been proven. What we know for certain is simply this: consciousness exists. Every person experiences it, yet no one fully understands where it comes from. And perhaps that mystery is not something to fear. It may simply be another reminder that the universe is far deeper than our current understanding. The same universe that formed stars and galaxies also formed minds capable of wondering about their own existence. You are, in a very real sense, a small part of the cosmos becoming aware of itself. And once we begin thinking about the universe in that way, another quiet question naturally appears. If we are here observing the universe, then how did the universe itself begin? When we look up at the night sky, it is easy to feel as though the universe has always existed exactly as it is. The stars appear steady and timeless, scattered across the darkness like quiet lanterns. For most of human history, people believed the cosmos was eternal, stretching endlessly into the past without a beginning. But modern science tells a very different story. According to our best observations, the universe has not always looked the way it does today. In fact, it has been expanding for billions of years. Galaxies are slowly drifting farther apart, like dots on the surface of a balloon as it gently inflates. By carefully measuring the movement of distant galaxies, astronomers discovered that the farther away a galaxy is, the faster it appears to be moving away from us. This pattern suggests that space itself is stretching. If we follow this expansion backward in time, the universe becomes smaller, hotter, and denser. Continue far enough, and all matter and energy appear to converge into an extremely compact state. This moment is what scientists call the Big Bang. Approximately 13.8 billion years ago, the universe began expanding from an unimaginably hot and dense beginning. Space itself started to stretch outward, carrying matter and energy with it. Over time, the universe cooled, allowing particles to form, then atoms, then the first stars and galaxies. In many ways, this discovery is one of the greatest achievements of modern science. It provides a powerful explanation for how the universe evolved into the vast cosmic structure we observe today. Yet the deeper we look into this origin story, the more mysterious it becomes. Because the Big Bang Theory explains how the universe expanded after its earliest moment. It describes the evolution of the cosmos once space and time already existed. But it does not explain why the universe exists at all. What existed before the Big Bang? Did time itself begin at that moment? Or was there something earlier that led to it? Some physicists suggest that the concept of before may not even make sense if time itself started during the Big Bang. Others have proposed fascinating possibilities. Perhaps our universe is part of a much larger multiverse, where countless universes appear and disappear over unimaginable stretches of time. In that case, the Big Bang might simply be one small event within a much larger cosmic process. Another idea suggests that the universe may cycle through endless periods of expansion and contraction, growing outward and then collapsing inward again, repeating the process across eternity. These theories are intriguing, but none have been proven. At its core, the question remains astonishingly simple and incredibly difficult to answer. Why is there something instead of nothing? Why does a universe exist at all, filled with galaxies, stars, oceans, mountains, and living minds capable of wondering about their own existence? For now, science does not know. But perhaps there is something peaceful about that uncertainty. The universe still holds its deepest secrets close. And as we continue this quiet journey through its mysteries, another one begins to emerge. Because most of the universe, it turns out, is made of something we cannot even see. For a long time, scientists believed that the universe was made only of the things we could see. Stars, planets, clouds of gas, dust drifting between galaxies. These visible objects seemed to form the entire cosmic landscape. But as telescopes became more powerful and measurements more precise, astronomers began to notice something strange. Galaxies were moving in ways that did not make sense. When scientists measured how stars orbit around the center of a galaxy, they expected the outer stars to move more slowly than the inner ones. This is exactly how planets behave in our own solar system. The farther a planet is from the sun, the slower its orbit. But galaxies were behaving differently. Stars at the edges of galaxies were moving much faster than expected. In fact, they were moving so quickly that, according to the visible mass of the galaxy, they should have been flung out into space long ago. Yet they remained in place, orbiting calmly as if something invisible was holding them there. This puzzle led scientists to an astonishing conclusion. Most of the matter in the universe cannot be seen. Astronomers call it dark matter. The word dark does not necessarily mean black or shadowy. It simply means that this matter does not interact with light. It does not glow, reflect, or absorb light in ways our telescopes can detect. And yet, its presence is unmistakable. Dark matter reveals itself through gravity. It pulls on stars and galaxies, shaping the structure of the cosmos. By studying these gravitational effects, scientists estimate that ordinary matter, the kind that forms stars, planets, oceans, and living beings, makes up only about 5% of the universe. 5%. The remaining 27% appears to be dark matter, a mysterious substance that surrounds galaxies like an invisible halo. Despite decades of research, scientists still do not know exactly what dark matter is made of. It might consist of unknown particles that interact very weakly with normal matter. Around the world, deep underground laboratories have been built to search for these particles, shielded from cosmic radiation by layers of rock. Sensitive detectors wait patiently for the faintest signal, a tiny collision that might reveal the presence of dark matter passing silently through the Earth. So far, these experiments have not provided a clear answer. Particle accelerators have also searched for hints of dark matter by recreating conditions similar to those just after the Big Bang. Yet even with enormous machines and advanced technology, the true nature of dark matter remains hidden. Imagine that for every star shining in the sky, there is a vast amount of unseen matter surrounding it, shaping its motion but remaining completely invisible. The universe we observe is only a small part of a much larger cosmic structure. And if dark matter already sounds mysterious, there is something even stranger waiting beyond it. Because scientists have discovered another invisible ingredient in the universe, something that does not pull objects together like gravity. Instead, it appears to be pushing the universe apart. If dark matter was the first great surprise waiting in the darkness of the universe, then what scientists discovered next was even more astonishing. For most of the 20th century, astronomers believed they understood the overall behavior of the universe. Since the Big Bang, space had been expanding, carrying galaxies farther and farther apart. Gravity, the force that pulls matter together, was expected to slowly resist this expansion. Many scientists assumed that over billions of years, the expansion of the universe would gradually slow down. The gravitational pull of galaxies and clusters of matter should act like a gentle brake on the cosmic expansion. But in the late 1990s, two independent teams of astronomers made a discovery that changed this picture completely. They were studying distant exploding stars known as supernovae. These brilliant stellar explosions can shine with such predictable brightness that astronomers use them as cosmic measuring tools. By observing how bright these supernovae appear from Earth, scientists can estimate how far away they are. When researchers compared the distance of these supernovae with the rate at which the universe was expanding, something unexpected appeared in the data. The expansion of the universe was not slowing down, it was speeding up. Instead of gravity gradually pulling everything back together, galaxies were moving away from one another faster and faster as time passed. This result was so surprising that many scientists initially suspected an error in the measurements. But as more observations were collected and analyzed, the evidence became impossible to ignore. Something was pushing the universe outward. This mysterious influence was given a name: dark energy. Unlike dark matter, which pulls objects together through gravity, dark energy appears to act in the opposite way. It behaves like a kind of energy built into the fabric of space itself, gently pushing everything apart. Today, scientists estimate that dark energy makes up roughly 68% of the entire universe. That means the largest ingredient in the cosmos is something we do not understand. No telescope has ever directly observed dark energy. It cannot be captured in laboratories or studied with particle detectors. Its presence is revealed only through the way the universe expands. Some physicists believe dark energy may be related to a property of empty space known as vacuum energy, a subtle energy that exists even in the absence of matter. But when scientists attempt to calculate this energy using known theories of physics, the results do not match what we observe in the universe. The difference between theory and observation is enormous, one of the largest mismatches in all of scientific history. Other researchers have proposed that our understanding of gravity itself may be incomplete, and that new physical laws could eventually explain the accelerated expansion of the cosmos. For now, the truth remains unknown. The universe is expanding faster and faster, guided by a force we cannot see and do not yet fully understand. And yet, even these enormous cosmic mysteries are only part of the story, because another puzzle lies much closer to home. It exists on our own planet, a question about how life itself began. Life surrounds us so completely that it often feels ordinary. Plants grow quietly from the soil. Birds move through the sky. Tiny organisms live in places so extreme that sunlight never reaches them. Oceans, forests, deserts, and even the air itself are filled with living things. And yet, when scientists ask one simple question, the answer becomes surprisingly unclear. How did life begin? Today, we understand an enormous amount about how living organisms function. Cells contain intricate molecular machinery that reads genetic instructions stored in DNA. Proteins carry out countless chemical tasks inside the cell, building structures, repairing damage, and controlling the processes that keep an organism alive. Evolution explains how life changes over time. Small genetic variations appear in populations of organisms, and those variations that improve survival tend to persist through generations. But evolution describes how life develops once it already exists. It does not fully explain how the first living system appeared in the first place. Several billion years ago, the young Earth was a very different world. Volcanoes erupted frequently. Lightning storms flashed across a thick atmosphere. The oceans contained a rich mixture of chemicals, slowly interacting under the influence of heat and energy. Some scientists believe that in this early environment, simple molecules gradually combined to form more complex structures. Over time, certain molecules may have developed the ability to copy themselves. Once self-replication began, natural selection could start shaping those molecules into increasingly complex forms. One popular idea is known as the RNA world hypothesis. RNA is a molecule that can both store information and perform chemical reactions. In this theory, early RNA molecules may have acted as the first primitive genetic systems, eventually leading to the DNA-based life we see today. Another possibility points to deep-sea hydrothermal vents. These vents release hot, mineral-rich fluids from beneath the ocean floor, creating environments where chemical reactions can occur continuously. Some researchers believe these locations may have provided the energy and materials needed for the earliest biological structures to form. There is even a theory suggesting that the basic ingredients of life may have arrived from space. Certain meteorites contain complex organic molecules, and it is possible that early Earth received some of the building blocks of life from distant parts of the cosmos. Despite these ideas, the exact moment when chemistry crossed the boundary into biology remains unknown. At some point, non-living molecules organized themselves into a system capable of maintaining structure, using energy, and reproducing. That transition from non-life to life is one of the most extraordinary events in the history of the universe. Every tree, Every animal, every person alive today can trace their existence back to that first fragile beginning, and yet we still do not know exactly how it happened. Life emerged from the quiet chemistry of an ancient planet, and the details of that transformation remain hidden somewhere in the deep past. But even after life appeared, another mystery soon followed. Because once living creatures developed brains, something even stranger began to emerge: the sense of being a self. As life slowly evolved on Earth, organisms began to develop nervous systems. At first, these systems were simple networks of cells that helped creatures respond to their environment. Over millions of years, those networks became more complex, eventually forming brains capable of processing enormous amounts of information. With this growing complexity came something remarkable. Animals did not just react to the world anymore, they began to experience it. Somewhere within the activity of the brain, a sense of identity appeared, a feeling that there is a center inside the mind, a place where thoughts, memories, and emotions seem to gather. We call this the sense of self. When you wake up in the morning, there is a quiet recognition that you are the same person who fell asleep the night before. You remember events from yesterday. You recognize your own name. Your mind holds a continuous story about who you are. But when neuroscientists study the brain carefully, they find something surprising. There is no single place where the self exists. The brain contains billions of neurons communicating across many different regions. Some areas process vision, others manage movement, language, memory, or emotions. Each part contributes to different aspects of experience. Yet nowhere in the brain is there a central control room where a self sits observing everything. Instead, the sense of identity appears to emerge from the interaction of many different systems working together. Memory networks recall past experiences. Emotional centers add meaning and feeling. Sensory areas bring information from the outside world. All of these processes combine to create the ongoing narrative that we experience as our personal identity. But here's the mystery. How does this distributed activity produce the feeling of being a single, unified person? How does a collection of neural signals create the sense of I? Some researchers suggest that the brain constantly constructs a model of the self, a kind of internal story that helps organize experiences and guide decisions. This model allows us to navigate the world, remember our past, and imagine possible futures. Others believe the sense of self may simply be an illusion created by the brain, a useful tool rather than a fundamental entity. Yet even if the self is a constructed experience, the feeling of being someone remains deeply real. You still wake each morning with the sense that your thoughts belong to you, your memories feel personal, your hopes and fears seem connected to the same identity moving forward through time. In rare neurological conditions, this sense of self can change or even temporarily disappear. Studying these unusual cases gives scientists small clues about how the brain generates identity. But the full explanation remains incomplete. The brain creates a sense of self from countless interactions between neurons, but the exact process through which those interactions become personal experience is still not fully understood. You are, in a very real way, a mystery to yourself. And once we begin thinking about the strange nature of the mind, another curious question appears. Why do certain sounds, especially music, move us so deeply? There are moments when a piece of music reaches somewhere deep inside the human mind. A quiet piano melody, the rising swell of strings, or a voice carrying a simple tune can suddenly create a powerful emotional response. Sometimes it brings comfort. Sometimes it stirs memories long forgotten. Occasionally, it can even bring tears without any clear explanation. This reaction is almost universal. Across cultures and throughout history, human beings have created music. Ancient bone flutes discovered by archaeologists suggest that people were making music more than 40,000 years ago. Long before written language, long before cities and technology, early humans were already shaping sounds into rhythm and melody. But why? From a scientific perspective, music is simply organized sound. Vibrations travel through the air, reach the ear, and are converted into electrical signals that the brain interprets. In theory, these signals are not very different from the sounds of wind, rain, or footsteps, yet music feels different. Certain arrangements of notes can create chills along the skin. A particular harmony may cause the heart to beat slightly faster. Some songs have the power to bring thousands of strangers together in shared emotion. Researchers studying the brain have found that music activates several different regions at once. Areas involved in emotion, memory, and reward become active while listening to music. Chemicals such as dopamine, often associated with pleasure, may be released during especially powerful musical moments. But this still does not fully explain the experience. Why should a specific sequence of vibrations in the air create such deep emotional reactions? Why do certain melodies feel joyful while others feel sad or nostalgic? And why does music often trigger vivid memories of moments from the past? One idea is that music may be closely connected to the rhythms of human communication. The tone of a voice, the rise and fall of speech, and the emotional patterns in conversation may share similarities with musical structure. In this view, music might amplify the emotional signals that humans naturally respond to in language. Another theory suggests that music evolved as a social bonding tool. Groups that shared music and rhythm may have developed stronger cooperation and unity, improving their chances of survival. But even these ideas leave many questions unanswered. Music can move people across cultures who do not share the same language. A melody written centuries ago can still create emotion today. And sometimes a simple sequence of notes can feel more powerful than words. There is something about music that reaches into the emotional landscape of the mind in a way science has not fully mapped. It reminds us that the human brain is not only a machine for logic and reasoning, but also a place where patterns of sound can become meaning, memory, and feeling all at once. In a quiet way, music reveals another layer of mystery inside the mind. And outside the mind, in the skies above, another strange phenomenon has puzzled observers for centuries. A glowing sphere of light that appears during storms, drifting silently through the air. A phenomenon known as ball lightning. Thunderstorms have always carried an element of mystery. Dark clouds gather slowly across the sky. The air grows heavy, and flashes of lightning suddenly split the darkness with brilliant light. For centuries, people have watched these storms with a mixture of fascination and respect, aware of the enormous energy contained within them. Ordinary lightning is already an impressive natural phenomenon. A bolt of lightning can heat the surrounding air to temperatures hotter than the surface of the sun, creating a sudden shock wave that we hear as thunder. Scientists understand many aspects of how lightning forms, from the buildup of electrical charge inside storm clouds to the sudden release of that energy toward the ground. But there is another, much stranger type of lightning that has puzzled observers for hundreds of years. It is called ball lightning. Instead of a sharp flash that disappears instantly, witnesses describe a glowing sphere of light drifting slowly through the air. Sometimes it appears during a thunderstorm. Sometimes it shows up just after the storm has passed. The glowing ball may be small, about the size of a tennis ball, or much larger, sometimes as wide as a beach ball. People have reported that these spheres float silently above the ground, move through open fields, or even pass through windows and doors without leaving visible damage. Some witnesses say the light is white or yellow, while others describe orange or blue colors shimmering inside the sphere. In many cases, the ball slowly fades away after several seconds. In other reports, it suddenly disappears with a small explosion or popping sound. For a long time, scientists were skeptical of these stories. Ball lightning seemed so unusual that many researchers suspected the reports were misunderstandings or optical illusions created by normal lightning. However, the phenomenon has been described by pilots, engineers, scientists, and many careful observers across different countries and centuries. Some modern instruments have even recorded events that appear similar to ball lightning, suggesting that the phenomenon may indeed be real. The difficulty is explaining what it actually is. Several ideas have been proposed. One possibility is that ball lightning is a form of plasma, a hot cloud of charged particles created by the intense energy of a lightning strike. Another theory suggests that certain chemical reactions in the air may produce glowing spheres of gas that briefly sustain themselves. Some researchers believe microwaves produced during a lightning strike could trap energy in a small region of air, creating a floating ball of light. Laboratory experiments have produced phenomena that look somewhat similar, but none of these explanations has yet accounted for all the features witnesses describe. Ball lightning remains one of the rare atmospheric mysteries that science has not fully solved. It appears suddenly, behaves in unexpected ways, and then vanishes, leaving behind more questions than answers. Nature sometimes reminds us that even familiar forces like lightning can still hide unusual surprises. And when scientists step back from storms and look at the deeper laws governing the universe itself, they encounter another puzzle, one involving the most familiar force of all: gravity. Gravity is one of the most familiar forces in the universe. It is the reason objects fall toward the ground when you drop them. It keeps the moon orbiting the Earth and holds the planets in their paths around the sun. On a much larger scale, gravity gathers enormous clouds of gas together until they ignite into stars, and it binds entire galaxies into vast rotating systems. Without gravity, the universe would look completely different. Matter would drift aimlessly through space, never gathering into the structures that eventually gave rise to planets, oceans, and living creatures. For something so important, gravity might seem well understood. In many ways, it is. More than 300 years ago, Isaac Newton described gravity as a force that attracts objects with mass toward one another. His equations explained the motion of planets and falling objects with remarkable accuracy. Later, in the early 20th century, Albert Einstein introduced a deeper description through his theory of general relativity. According to Einstein, gravity is not simply a force pulling objects together. Instead, massive objects like stars and planets curve the fabric of space and time itself. Other objects move along these curves, which is why they appear to be pulled by gravity. This idea has passed many experimental tests. Observations of orbiting planets, bending light from distant stars, and even the recent detection of gravitational waves have all confirmed predictions made by Einstein's theory. And yet, despite these successes, gravity still contains mysteries. One of the strangest is that gravity is incredibly weak compared to the other fundamental forces of nature. There are four basic forces known in physics: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. These forces govern everything from the structure of atoms to the movement of galaxies. But gravity is far weaker than the others. For example, the electromagnetic force between two tiny charged particles can easily overcome the gravitational pull of the entire Earth. A small refrigerator magnet can lift a paperclip against the gravity of an entire planet. Why gravity is so weak remains an open question. Some physicists have proposed that gravity may spread into extra dimensions beyond the ones we can perceive. If this is true, part of gravity's strength could be leaking into hidden dimensions of space, making it appear weaker in the three-dimensional world we experience. Others believe the explanation may come from a deeper unified theory that connects all fundamental forces in a single framework. Scientists have been searching for such a theory for decades, hoping it will reveal why gravity behaves so differently from the other forces. And there is also the challenge of combining gravity with quantum mechanics, the theory that describes the behavior of particles at extremely small scales. So far, these two pillars of physics do not fully fit together. Gravity works beautifully on cosmic scales, guiding galaxies and shaping the universe. Quantum mechanics works perfectly within atoms. But bringing the two theories together into a single complete description of nature remains one of the greatest unsolved problems in science. And when gravity becomes extremely strong, another mystery appears. One that exists in the darkest regions of space, inside black holes. Among all the strange objects that exist in the universe, few are as mysterious as black holes. These cosmic structures form when enormous amounts of matter collapse under their own gravity, compressing into a region so dense that the pull of gravity becomes almost unimaginable. When a massive star reaches the end of its life, it can no longer support itself against its own weight. The core collapses inward with tremendous force, and if enough mass is present, the collapse continues until a black hole forms. At that point, gravity becomes so strong that nothing can escape from it. Not dust, not gas, not even light itself. The boundary surrounding a black hole is called the event horizon. This is often described as the point of no return. Once something crosses this invisible boundary, it cannot travel back out into the universe. From the outside, black holes appear silent and dark, but they reveal their presence through their effects on nearby matter. Gas and dust falling toward a black hole become extremely hot and bright as they spiral inward, producing intense radiation that telescopes can detect. Scientists have even captured images of the shadow of a black hole using networks of radio telescopes spread across the Earth. These images show the glowing ring of matter surrounding the dark center where the black hole resides. Yet the most fascinating question lies beyond the event horizon. What actually happens inside a black hole? According to Einstein's theory of general relativity, the matter inside continues collapsing toward a point of infinite density called a singularity. In this region, the known laws of physics break down. space and time themselves become distorted beyond anything we currently understand. However, the idea of an infinite density creates serious problems in physics. Infinities often signal that a theory is incomplete, suggesting that new principles are needed to describe what truly happens in these extreme conditions. Quantum mechanics, the theory that governs tiny particles, also plays a role here. When scientists attempt to combine quantum effects with the intense gravity inside a black hole, the mathematics becomes extremely complicated. This has led physicists to suspect that a deeper theory, sometimes called quantum gravity, may eventually explain the true nature of black holes. Another mystery concerns information. In physics, information about a system is generally believed to be conserved. If you know the exact state of all particles in a system, you should be able to trace how they evolve over time. But if matter falls into a black hole and disappears completely, what happens to the information it contained? Does it vanish forever? Is it somehow stored on the surface of the event horizon? Or does it escape in a subtle way we have not yet discovered? Scientists have debated this black hole information paradox for decades. Some ideas suggest that information may be encoded in faint radiation emitted by black holes over extremely long periods of time. Others propose that space itself may store information in ways we do not yet understand. For now, the interior of a black hole remains hidden from observation, a place where our best theories reach their limits. And yet, even the strange behavior of black holes is connected to another mystery that emerges from the smallest scales of reality, the strange and counterintuitive world of quantum physics. When scientists began studying the smallest building blocks of matter, they discovered something deeply surprising. The world of atoms and particles does not behave the way our everyday experience would suggest. Instead, it follows rules that often seem strange, unpredictable, and sometimes even impossible. This strange realm is described by a field of science known as quantum mechanics. In our daily lives, objects appear to have clear positions and predictable behavior. A ball rolls across the floor, a leaf falls from a tree, and we can easily imagine where these objects will move next. But at the scale of atoms and subatomic particles, certainty begins to dissolve. Particles such as electrons do not behave like tiny solid spheres. Instead, they exist in a strange state that physicists describe as a probability wave. Until a measurement is made, an electron does not have a single definite position. It exists in many possible positions at once. This phenomenon is known as quantum superposition. In experiments, particles can appear to travel through multiple paths simultaneously, only settling into a single outcome when observed. One famous experiment, called the double-slit experiment, demonstrates this effect clearly. When individual particles pass through two tiny openings, they create an interference pattern on the other side, as if each particle somehow passed through both openings at the same time. Even stranger is a phenomenon known as quantum entanglement. When two particles become entangled, their properties become linked in a very unusual way. If scientists measure one particle, the other instantly reflects a corresponding change, no matter how far apart the particles are separated. This connection appears to occur instantly, even across enormous distances. Albert Einstein famously referred to this behavior as spooky action at a distance because it seemed to challenge the idea that information cannot travel faster than the speed of light. Experiments over many decades have repeatedly confirmed that quantum entanglement is real. Particles truly can share a connection that behaves in ways classical physics cannot easily explain. Yet while the mathematics of quantum mechanics predicts these outcomes with extraordinary accuracy, the deeper meaning behind these phenomena remains uncertain. What exactly is happening during quantum superposition? How can particles exist in multiple possibilities at once? What is the true nature of the connection between entangled particles? Physicists have proposed several interpretations. Some believe that every possible outcome actually occurs in separate universes, branching off into separate realities. Others suggest that the act of observation itself plays a role in determining the final state of a particle. There are also ideas proposing that hidden variables, not yet discovered, may influence the behavior of quantum systems. So far, none of these interpretations has been universally accepted. Quantum mechanics remains one of the most successful scientific theories ever developed, yet its deeper meaning continues to puzzle even the experts who study it. It reminds us that the universe may operate according to principles that are very different from our everyday intuition. And when scientists look beyond particles and atoms to the structure of the universe itself, they encounter another puzzle, a question about the shape and size of reality itself, whether the universe might be far larger and stranger than we imagine.
When we look out into space with powerful telescopes, the universe appears unimaginably vast. Galaxies stretch across billions of light years, each one containing hundreds of billions of stars. Between these galaxies lies an enormous darkness, a quiet ocean of space where only faint traces of matter drift slowly through the cosmic night. But even with our most advanced instruments, we may be seeing only a small part of the full picture. One of the questions scientists still struggle with is surprisingly simple. How big is the universe? The observable universe, the region of space we can currently detect with telescopes, extends roughly 93 billion light-years across. This number may sound enormous, and it certainly is. Light from the most distant objects we observe has been traveling toward us for billions of years before finally reaching our instruments. Yet the observable universe is limited by the speed of light. Because the universe began about 13.8 billion years ago, light from regions farther away than a certain distance simply has not had enough time to reach us yet. There may be enormous regions of space beyond our cosmic horizon that remain permanently hidden from observation. This means the universe could be much larger than what we see. Some cosmologists believe the universe might extend infinitely in all directions, with galaxies continuing endlessly beyond the limits of our visible region. If this is true, there may be distant areas of space where conditions resemble our own cosmic neighborhood, possibly even containing planets similar to Earth. Other scientists suggest that the universe might be finite but curved, somewhat like the surface of a sphere, but in higher dimensions. In this case, traveling far enough in one direction might eventually bring you back to the starting point, although the distances involved would be so vast that such a journey would be almost impossible. Another idea proposes that our universe could be only one part of a much larger structure known as the multiverse. In some versions of this theory, countless universes may exist, each with its own physical laws, constants, and properties. Some universes might contain stars and galaxies similar to ours. Others could be dramatically different, perhaps containing entirely unfamiliar forms of matter and energy. These ideas emerge naturally from certain models of cosmology and quantum physics, but so far there is no direct evidence proving that multiple universes exist. Testing such ideas is extremely difficult because any other universe would likely lie beyond the limits of what we can observe. Still, the possibility remains intriguing. Our universe may not be the entire story. It could be one small region within a much larger and more complex cosmic landscape. And if the universe truly extends far beyond our view, it raises another fascinating question. Among the countless stars scattered across the cosmos, could life exist elsewhere? Are we alone in this vast universe, or are there other minds somewhere among the distant stars, quietly wondering about the same mysteries?
When we look up at the night sky, it is easy to feel both small and curious at the same time. The stars appear quiet and distant, scattered across the darkness like countless tiny lights. Yet each one of those points of light is often a sun, sometimes surrounded by planets of its own. For most of human history, people could only wonder whether those distant worlds might exist. Today, however, astronomers have begun to find them. Over the past few decades, scientists have discovered thousands of planets orbiting stars beyond our solar system. These worlds are known as exoplanets. Some are enormous gas giants, larger than Jupiter. Others are rocky planets, closer in size to Earth. A few orbit their stars at distances where temperatures might allow liquid water to exist on their surfaces. Since water is essential for life as we know it, these planets attract particular attention from researchers. The discovery of so many planets has changed how scientists think about the universe. Our galaxy alone contains hundreds of billions of stars. If even a small fraction of those stars have planets, then the number of worlds in our galaxy could be staggering. Some estimates suggest there may be more planets than stars in the Milky Way. This leads naturally to an exciting question. If planets are so common, could life also be common? Life on Earth appeared relatively early in our planet's history. Geological evidence suggests that microorganisms may have existed as far back as 3.5 to 4 billion years ago. In cosmic terms, that is not very long after Earth itself formed. This has led some scientists to wonder whether life might emerge easily when the right conditions are present. Yet, despite searching for decades, we have not yet found clear evidence of life beyond our planet. This puzzle is sometimes called the Fermi paradox. Given the enormous number of stars and planets in the universe, it seems reasonable to expect that intelligent civilizations might have arisen elsewhere. Some of those civilizations could be millions of years older than ours. If that is the case, why have we not detected any signs of them? Radio telescopes have scanned the skies for artificial signals that might indicate advanced technology. So far, no confirmed signal has been found. There are many possible explanations. Perhaps intelligent life is extremely rare. It may require a very specific combination of environmental conditions that seldom occur. Another possibility is that technological civilizations do not last very long. They may disappear before spreading far into space. It is also possible that advanced civilizations communicate in ways we do not yet understand, using technologies beyond our current ability to detect. And of course, the universe is inimaginably vast. Signals traveling across such distances may simply take too long to reach us. For now, the question remains open. Somewhere among the countless stars, there may be other worlds with oceans, clouds, and living ecosystems. There may even be other minds looking up at their own night skies, wondering whether they are alone. And here on Earth, another quiet mystery exists much closer to home, hidden within the extraordinary abilities of the human brain itself.
The human brain is often described as the most complex structure known in the universe. Inside a space not much larger than two hands held together exists a network of roughly 86 billion neurons, each one communicating with thousands of others through tiny electrical and chemical signals. Every memory you have ever formed, every thought you have ever experienced, and every emotion you have ever felt is connected to patterns of activity within this intricate system. Yet, despite decades of research and increasingly advanced technology, scientists are still discovering how little they fully understand about the brain. One particularly fascinating mystery is how the brain stores memories. When you remember a moment from your past, perhaps a childhood room, a familiar voice, or the smell of rain on a warm evening, something inside your brain reconstructs that experience. It may feel as if the memory has been preserved exactly as it happened, like a recording stored somewhere inside the mind. But the reality appears to be far more complex. Memories are not stored in a single location. Instead, they are distributed across many networks of neurons. Different parts of the brain contribute different pieces of the memory. One area may store visual details, another emotional associations, and another the sounds connected to the event. When you recall a memory, the brain reconstructs the experience by activating many of these networks at once. This reconstruction process may explain why memories can change over time. Each time a memory is recalled, it can be subtly altered as new information becomes connected to it. Over many years, the brain may reshape a memory so that it feels vivid and real, even though certain details have shifted. Another mystery involves how memories are preserved for such long periods. Some memories remain clear for decades, even though the molecules and cells within the brain are constantly being replaced and renewed. Scientists believe that patterns of connection between neurons, known as synapses, play a role in storing long-term memories. But the precise biological mechanisms behind this process are still being studied. Even more surprising is the brain's ability to imagine things that have never happened. Humans can create entire fictional worlds in their minds. We can imagine future events, invent stories, design technologies that do not yet exist, and explore ideas far beyond our immediate environment. This ability to simulate possibilities may be one of the most powerful tools evolution has given us. It allows the mind to explore outcomes before they happen, helping us plan, adapt, and create. Yet, the origin of imagination itself remains mysterious. How does the brain generate ideas that have never existed before? How does a network of neurons produce creativity, art, and innovation? The brain is not just a processor of information, it is also a generator of possibility. Every moment, billions of tiny signals move through this living network, producing the thoughts that shape human experience. And sometimes the brain does something even more curious.
It can convince the body to heal itself even when the treatment being given has no medical effect at all, a phenomenon known as the placebo effect.
The human body has many systems designed to protect and repair itself. When you are injured, cells rush to heal damaged tissue. When harmful bacteria enter the body, the immune system responds with a complex defense designed to remove the threat. These processes are the result of millions of years of biological evolution. But there is another phenomenon within medicine that scientists still find surprisingly mysterious. It is called the placebo effect. A placebo is a treatment that has no direct medical action. It might be a pill made of sugar, a harmless injection of saline solution, or a procedure that appears medical but does not actually change anything in the body. In theory, a placebo should do nothing. And yet, in thousands of clinical studies, patients who receive placebos often report real improvements in their symptoms. Pain may decrease, nausea may fade. Some people even show measurable changes in heart rate, blood pressure, or brain activity after receiving a treatment that contains no active medicine. At first glance, this might seem like simple imagination. Perhaps people only believe they feel better. But the placebo effect appears to be more complex than that. Brain scans show that when people expect relief from pain, certain areas of the brain release natural chemicals, such as endorphins. These chemicals can reduce pain signals in ways that resemble the effects of real medications. In other words, the expectation of healing can sometimes trigger genuine biological changes. This connection between belief and biology raises fascinating questions. How can a thought influence the physical state of the body? Why does expectation sometimes produce measurable improvements in health? Researchers believe the brain may act as a powerful regulator of the body's internal systems. When a person believes they are receiving help, the brain may adjust chemical signals, hormone levels, or immune responses in ways that promote recovery. Yet, the exact mechanisms behind these changes are still not fully understood. Even more interesting is the opposite effect, known as the nocebo effect. In this case, negative expectations can create harmful symptoms. If someone believes a harmless treatment will cause side effects, they may begin to experience headaches, nausea, or other discomforts even though the treatment itself cannot produce those effects. These phenomena suggest that the relationship between mind and body is far more intertwined than we once imagined. Thoughts, expectations, and beliefs appear capable of influencing physical processes in subtle but powerful ways. Medicine continues to study these effects carefully, both to understand the biology behind them and to ensure that treatments are tested accurately in clinical trials. But the placebo effect also reminds us that the human mind is not simply observing the body, it is participating in its experience. Our thoughts and perceptions are not separate from our physical existence. They are deeply connected to it. And just as the mind can influence the body, the universe itself contains connections that seem to operate across astonishing distances. Connections that appear to link particles together instantly, even when they are separated by vast stretches of space. A phenomenon known as quantum entanglement.
In the strange world of quantum physics, particles do not always behave the way we expect. At the smallest scales of reality, matter follows rules that seem almost impossible when compared to the ordinary experiences of everyday life. One of the most fascinating examples of this is a phenomenon known as quantum entanglement. When two particles become entangled, their properties become connected in a very unusual way. Even if the particles move far apart from one another, the state of one particle remains linked to the state of the other. If a scientist measures one particle and discovers a particular property, such as its spin or polarization, the other particle instantly reflects a corresponding state. What makes this so mysterious is that the particles may be separated by enormous distances. They might be located in different laboratories, different cities, or even on opposite sides of the planet. Yet, the connection between them appears to happen immediately. There is no delay, no signal traveling through space at a measurable speed. The relationship between the particles seems to exist beyond the limits of ordinary communication. This puzzled scientists for many years. Albert Einstein famously described quantum entanglement as spooky action at a distance. He was uncomfortable with the idea because it seemed to challenge a fundamental principle of physics, that nothing can travel faster than the speed of light. Einstein suspected that quantum mechanics might be incomplete. He believed that hidden variables, factors not yet discovered, might eventually explain this strange behavior. However, experiments conducted over the past several decades have repeatedly confirmed that entanglement behaves exactly as quantum theory predicts. Pairs of entangled particles truly do exhibit correlated behavior, even when separated by large distances. Careful tests have ruled out many possible explanations involving hidden signals or classical communication. This does not mean that information is traveling faster than light in the traditional sense. The phenomenon cannot be used to send messages instantly across space. Yet, the connection between the particles still challenges our intuition about how reality works. Physicists continue to explore the deeper meaning of entanglement. Some interpretations suggest that entangled particles may share a deeper level of connection within the structure of reality itself. Others propose that quantum information may be woven into the fabric of space in ways we do not yet fully understand. Despite the mystery, entanglement is not only a theoretical curiosity. Scientists are now using it to develop new technologies, such as quantum computing and quantum communication systems. These technologies could eventually allow information to be processed and transmitted in ways far beyond the capabilities of current computers. Even so, the underlying reason entanglement exists remains one of the great puzzles of modern physics. It reminds us that the universe may be more interconnected than it first appears. At the smallest scales, particles separated by great distances may still share a relationship that science cannot fully explain. And if the universe behaves this strangely at the quantum level, it raises another fascinating question. Could the fabric of reality itself be more complex than the space and time we experience every day? For most of human history, space and time were thought to be simple and absolute. Space was seen as a vast, empty stage where events took place, while time moved forward steadily like the ticking of a cosmic clock. No matter where you were in the universe, time was assumed to pass at the same rate for everyone. But in the early 20th century, this understanding began to change. Albert Einstein introduced a revolutionary idea known as the theory of relativity. According to this theory, space and time are not separate things. Instead, they form a single, unified structure called space-time. This means that the universe is not simply a three-dimensional space with time flowing independently. Rather, space and time are woven together into a four-dimensional fabric that can bend, stretch, and curve. Massive objects such as stars and planets distort this fabric. Imagine placing a heavy ball on a stretched sheet of rubber. The sheet bends under the weight of the ball, creating a curved surface. If smaller objects move nearby, they follow the curves in the sheet, appearing to be pulled toward the heavier object. In a similar way, massive objects curve space-time around them. This curvature is what we experience as gravity. But relativity also revealed something even stranger. Time itself can change depending on motion and gravity. When an object moves extremely fast, close to the speed of light, time for that object slows down relative to a stationary observer. This effect is known as time dilation. Experiments with highly precise atomic clocks have confirmed that time truly does pass differently for objects moving at different speeds. Gravity also affects time. The stronger the gravitational field, the slower time passes. Near extremely massive objects like neutron stars or black holes, this effect becomes very significant. An observer close to such an object would experience time passing more slowly compared to someone far away. These discoveries have been confirmed through many experiments and observations. Satellites in Earth's orbit must account for relativistic time effects in order for global positioning systems to work accurately. Yet, relativity also raises deeper questions about the nature of time itself. Is time truly flowing, or is it simply another dimension like space? Some physicists describe the universe as a block of space-time in which past, present, and future all exist together, while our experience of time moving forward may simply be a feature of human perception. Others believe that time may emerge from deeper physical processes that we do not yet fully understand. Even with modern physics, the true nature of time remains mysterious. We measure it constantly, we organize our lives around it, yet its deeper structure continues to puzzle scientists. The universe may not be the simple stage we once imagined. Space bends, time slows, reality behaves in ways that challenge our intuition. And when physicists look deeper into the structure of space-time, they encounter another profound mystery, one involving the possibility that space itself might not be continuous, but instead built from incredibly tiny pieces we have not yet discovered. When we imagine space, we often picture it as something smooth and continuous. It feels like an endless emptiness stretching in all directions, a quiet backdrop where galaxies drift and stars shine. But modern physics has begun to question whether space is truly continuous. At extremely small scales, far smaller than anything we can observe directly, space itself may have a structure. Some scientists believe that space-time might be composed of incredibly tiny units, much like matter is made from atoms. These smallest possible units are often described using a concept known as the Planck length. The Planck length is unimaginably small, about 100 billion times smaller than the size of an atom. At this scale, the smooth fabric of space-time predicted by Einstein's relativity may begin to break down. Instead of being perfectly continuous, space might resemble a kind of microscopic structure, a network of fundamental building blocks forming the foundation of the universe. Several theoretical models attempt to describe this possibility. One idea comes from a theory known as loop quantum gravity. In this framework, space-time is not infinitely divisible. Instead, it is made from tiny loops woven together, creating a granular structure at the smallest scales. Another approach, known as string theory, suggests that the fundamental ingredients of reality are not point-like particles, but extremely tiny vibrating strings of energy. According to this theory, the different vibrations of these strings give rise to the particles and forces we observe in the universe. String theory also proposes that the universe may contain additional spatial dimensions beyond the three we experience daily. These extra dimensions might be curled up so tightly that they remain invisible to us, existing only at extremely small scales. Both loop quantum gravity and string theory attempt to solve one of the biggest challenges in physics, combining general relativity with quantum mechanics. Relativity describes the behavior of gravity and large cosmic structures. Quantum mechanics describes the strange behavior of particles at very small scales. Each theory works extremely well in its own domain. But when scientists try to apply both theories at the same time, such as in the extreme conditions inside black holes or during the earliest moments of the universe, the mathematics becomes inconsistent. A complete theory of quantum gravity could reveal whether space itself has a fundamental structure. Yet testing these ideas is incredibly difficult. The scales involved are so tiny that even the most powerful particle accelerators cannot directly probe them. Much of the research remains theoretical, relying on mathematical models and indirect clues. Still, physicists continue to explore these possibilities, because understanding the true nature of space could unlock deeper insights about the universe. It could explain how gravity works at the smallest scales and how the universe behaved during its earliest moments. Perhaps space-time itself is not the smooth stage we once imagined, but a delicate structure woven from the smallest elements of reality. And if space may have a hidden structure, another question naturally follows. Could the universe itself be shaped by patterns and forces that extend far beyond what we can currently observe?
When scientists observe the universe on the largest scales, they noticed something remarkable. Galaxies are not scattered randomly through space. Instead, they form enormous patterns that stretch across hundreds of millions of light years. If we could step far enough away from our galaxy and look at the cosmos from a truly distant perspective, we would see that galaxies gather together into vast clusters. These clusters are connected by long filaments of matter, creating a structure sometimes called the cosmic web. Between these filaments lie enormous regions known as cosmic voids, places where very few galaxies exist. These empty spaces can be hundreds of millions of light years wide, forming some of the largest structures known in the universe. The overall pattern resembles a gigantic network, almost like the delicate threads of a spider's web spread across the cosmos. This structure did not appear instantly. It formed slowly over billions of years under the influence of gravity. After the Big Bang, matter in the young universe was distributed almost evenly, with only tiny variations in density. Over time, gravity amplified those small differences. Regions containing slightly more matter began attracting additional matter, gradually growing into the large-scale structures we see today. Computer simulations of the universe show that dark matter plays a crucial role in shaping this cosmic web.
Invisible halos of dark matter act as gravitational anchors, pulling ordinary matter into clusters and galaxies. Even though we cannot see dark matter directly, its influence becomes visible through the way galaxies arrange themselves across space. But the cosmic web raises a deeper mystery. Why did the universe begin with those tiny density variations in the first place? Observations of the cosmic microwave background, the faint radiation left over from the early universe, show subtle fluctuations in temperature across the sky. These fluctuations represent the earliest patterns that later evolved into galaxies and clusters. Some scientists believe these initial variations may have originated during a brief moment known as cosmic inflation. According to this theory, the universe experienced an extremely rapid expansion during the first fraction of a second after the Big Bang. During this expansion, tiny quantum fluctuations may have been stretched across enormous distances, eventually becoming the seeds of cosmic structure. While inflation explains many features of the observable universe, the exact mechanism behind it remains uncertain. What caused this sudden expansion? What physical process triggered it? These questions remain open. Yet the cosmic web reminds us that the universe is not chaotic or random. On the largest scales, it reveals a hidden order, a network shaped by gravity and time over billions of years. Every galaxy, including our own Milky Way, exists as part of this immense structure. And within one small corner of that vast web, on a quiet planet orbiting an ordinary star, life emerged and began asking questions about the universe itself. But even here on Earth, there are still mysteries waiting to be understood. Some of them are hidden deep within the oceans of our own planet.
Although humans have explored the surface of the moon and sent spacecraft far beyond the outer planets, much of our own planet remains surprisingly unknown. In particular, the deep oceans of Earth still hold mysteries that scientists are only beginning to understand. More than 70% of Earth's surface is covered by water, yet the vast majority of the ocean floor has never been directly explored by humans. Sunlight can only penetrate the upper layers of the ocean. Below a certain depth, darkness becomes complete, creating an environment very different from the world we experience on land. The pressure in the deepest parts of the ocean is enormous. At the bottom of trenches such as the Mariana Trench, the weight of the water above creates pressures more than 1,000 times greater than the air pressure at sea level. For a long time, scientists believed that such extreme conditions might make life impossible. But when researchers began sending deep-sea probes into these dark environments, they discovered something extraordinary. Life exists there. Strange creatures drift through the darkness, many producing their own light through a process called bioluminescence. Some fish carry glowing organs that help them attract prey or communicate with others of their species. Jellyfish-like animals float slowly through the deep waters, their faint lights flickering like distant stars. Perhaps even more surprising are the ecosystems found near hydrothermal vents on the ocean floor. These vents release extremely hot, mineral-rich water from deep within the Earth. The temperatures around these vents can be intense, yet entire communities of organisms thrive there. Giant tube worms, unusual crustaceans, and specialized bacteria live in these environments without relying on sunlight.
Instead of photosynthesis, which uses sunlight to create energy, these organisms rely on a process called chemosynthesis. They obtain energy from chemical reactions involving minerals released by the vents. This discovery changed how scientists think about life. If life can exist without sunlight, then life might also survive in dark environments elsewhere in the solar system. Some moons of Jupiter and Saturn are believed to contain vast oceans beneath their icy surfaces. Enceladus, a moon of Saturn, has been observed releasing plumes of water vapor into space, suggesting that liquid water may exist beneath its frozen crust. If these oceans contain hydrothermal activity similar to Earth's deep-sea vents, they might provide conditions where life could potentially emerge. For now, these ideas remain possibilities rather than confirmed discoveries. Yet the deep oceans of our own planet remind us that life can exist in places once thought impossible. The darkness of the sea floor hides ecosystems that function in ways very different from the surface world. Even on our own planet, exploration continues to reveal new species, new environments, and new questions. And sometimes, the mysteries of Earth are not found deep beneath the ocean, but high above us in the sky. Phenomena that appear suddenly, move silently, and leave scientists searching for explanations.
Throughout history, people have looked up at the sky and occasionally witnessed things they could not easily explain. Strange lights moving silently across the night. Objects appearing for a moment and then vanishing. Shapes or movements that seem to defy the familiar patterns of aircraft, stars, or satellites. In recent years, scientists and governments have begun referring to such observations with a more neutral term, unidentified aerial phenomena, often shortened to UAP. This name simply means that the object or light observed in the sky has not yet been identified. It does not automatically imply anything extraordinary. Many of these sightings eventually turn out to be balloons, unusual weather conditions, distant aircraft, or natural atmospheric effects. However, a small number of cases remain unexplained even after careful investigation. Modern technology has provided new tools for studying these phenomena. Military pilots, radar systems, and infrared cameras have occasionally recorded unusual aerial movements that do not easily match known objects. In some cases, objects appear to accelerate rapidly or change direction in ways that seem surprising. Yet interpreting these observations is complicated. Sensor data can sometimes produce misleading signals, and visual perception in the sky can be easily distorted by distance, lighting, and atmospheric conditions. Scientists approach these reports carefully. The goal is not to jump to extraordinary conclusions, but to collect reliable data and analyze it using the same scientific methods applied to other mysteries of nature. In fact, studying unexplained observations can sometimes lead to important discoveries. In the past, unusual atmospheric events such as sprites, blue jets, and other high-altitude lightning phenomena were once considered rare or doubtful reports. Later, with better instruments, scientists confirmed that these phenomena are real and part of Earth's complex weather systems. It is possible that some unexplained aerial sightings may eventually turn out to be natural atmospheric effects that are not yet fully understood. Others may be related to human technology, experimental aircraft, or misinterpretations of ordinary objects seen under unusual conditions. For now, the category of unidentified aerial phenomena simply represents observations that do not yet have clear explanations.
It reminds us that even in an age of satellites and advanced sensors, the skies above our planet can still surprise us. Science advances by investigating the unknown with patience and curiosity. Each unexplained observation becomes an opportunity to learn something new about the world around us. Sometimes the explanation turns out to be simple once more data is gathered. Other times it reveals a phenomenon that scientists had never previously recognized. The sky, after all, is part of a much larger system that includes the atmosphere, the sun, and the magnetic environment surrounding our planet. And that environment contains another fascinating mystery: a protective shield surrounding Earth, quietly deflecting invisible streams of particles traveling through space.
Earth is constantly surrounded by invisible streams of energetic particles traveling through space. These particles come from many sources, including the sun, distant stars, and violent cosmic events occurring far beyond our solar system. Without protection, these high-energy particles could gradually damage the atmosphere and make life on Earth far more difficult. Fortunately, our planet possesses a remarkable natural defense system. This protective shield is known as the magnetosphere. Deep within Earth's core lies a large region of molten iron and nickel. As this liquid metal slowly moves and circulates, it generates a powerful magnetic field that extends far into space. This magnetic field surrounds the planet, forming a protective bubble that interacts with the charged particles flowing through the solar system. When streams of charged particles from the sun, known as the solar wind, approach Earth, the magnetosphere deflects most of them away from the planet. The magnetic field guides these particles along curved paths, preventing them from directly striking the atmosphere. Without this magnetic shield, the solar wind could slowly strip away our atmosphere over long periods of time. Scientists believe something similar may have happened to Mars. Evidence suggests that Mars once had a thicker atmosphere and liquid water on its surface. But because Mars lacks a strong global magnetic field today, solar particles gradually eroded much of its atmosphere. Earth's magnetosphere therefore plays a crucial role in maintaining the conditions that allow life to exist on our planet. Yet this invisible shield also produces one of the most beautiful natural displays in the sky. When some solar particles follow magnetic field lines toward the polar regions of Earth, they collide with atoms in the upper atmosphere. These collisions release energy in the form of light, creating the shimmering curtains of color known as the aurora. In the northern hemisphere, this phenomenon is called the aurora borealis, or northern lights. In the southern hemisphere, it is known as the aurora australis. Green, red, and purple lights ripple across the sky in slow waves, forming patterns that seem almost alive. These displays are the visible result of invisible interactions between the Sun and Earth's magnetic field. However, the magnetosphere itself remains an active and complex system that scientists continue to study. The magnetic field surrounding Earth changes slowly over time. The location of the magnetic poles gradually shifts, and geological evidence suggests that throughout Earth's history, the magnetic field has occasionally reversed direction entirely. During such reversals, the north and south magnetic poles switch places. These events occur over thousands of years and have happened many times in the planet's past. Scientists are still studying exactly how and why these reversals occur within Earth's core. The magnetosphere reminds us that our planet is not isolated. It is constantly interacting with the larger environment of space. Invisible forces flow around us every day, shaping conditions on Earth in ways we rarely notice. And beyond this protective magnetic shield lies the vast region of space itself, a place where even empty space may not be as empty as it appears.
When we imagine empty space, it often seems like the simplest thing in the universe, a silent void with nothing in it. No matter, no light, no movement, just an endless emptiness stretching between the stars. But modern physics suggests that empty space may not be empty at all. Even in regions where no atoms exist, space itself may still contain energy. According to quantum physics, the vacuum of space is not perfectly quiet. Instead, it is filled with tiny fluctuations, constantly appearing and disappearing. These fluctuations occur because of the strange rules that govern the quantum world. In quantum theory, energy can briefly appear in small amounts as long as it disappears again quickly. This leads to the creation of what physicists call virtual particles. These particle pairs momentarily appear out of the vacuum and then vanish almost instantly. Although these particles cannot be observed directly in the usual way, their effects can be measured in certain experiments. One example is the Casimir effect. When two extremely smooth metal plates are placed very close together in a vacuum, they experience a tiny force pushing them toward each other. This force appears because the quantum fluctuations in empty space behave slightly differently between the plates than outside them. The discovery of this effect suggests that empty space contains a subtle background energy. Some physicists believe this vacuum energy may be connected to the mysterious dark energy that is causing the expansion of the universe to accelerate. However, when scientists attempt to calculate the amount of vacuum energy predicted by quantum theory, the result is enormously larger than the amount that appears to exist in the universe. In fact, the difference between theory and observation is one of the largest mismatches in the history of physics. The predicted energy is trillions upon trillions of times greater than the amount that appears to exist. Why the universe contains exactly the amount of dark energy that it does remains one of the deepest puzzles in cosmology. Empty space, it seems, is not simple at all. Instead, it may contain hidden energy, invisible fluctuations, and subtle properties that influence the behavior of the entire universe. This realization has changed the way physicists think about the vacuum. What once appeared to be nothing may actually be a complex and dynamic environment at the smallest scales. Even the quiet spaces between galaxies may contain activity that we cannot easily observe. And if space itself contains hidden energy, it raises another intriguing possibility. Perhaps the universe contains many layers of reality that exist beyond the limits of our current instruments. Layers that influence the cosmos in subtle ways, shaping the evolution of galaxies, stars, and even the structure of space itself. The deeper scientists look into the nature of reality, the more it becomes clear that the universe still holds many unanswered questions. And one of the oldest of those questions concerns something humans have been watching for thousands of years: the slow and endless passage of time itself.
Time feels like one of the most familiar parts of life. Every day follows a gentle rhythm. Morning becomes afternoon, afternoon fades into evening, and night eventually gives way to another sunrise. Clocks tick steadily, calendars turn page by page, and it seems natural to think of time as something that simply moves forward. But when scientists study time closely, they discover that its true nature may be far more mysterious than it appears. One of the biggest puzzles is why time seems to move in only one direction. In everyday experience, events always unfold from past to future. A glass can fall and shatter on the floor, but the broken pieces never spontaneously reassemble themselves into a perfect glass. A drop of ink spreads through water, but it never gathers itself back into a single drop again. This one-way direction of change is often called the arrow of time. Yet when physicists examine the fundamental laws of nature, many of those laws do not actually prefer a direction of time. The equations describing the motion of particles work almost equally well whether time moves forward or backward. So why does time appear to have a clear direction in our experience? One explanation comes from a concept known as entropy. Entropy is a measure of disorder within a system. According to the second law of thermodynamics, entropy tends to increase over time. Systems naturally move from more ordered states to more disordered ones. A neat stack of papers can become scattered across a desk, but the scattered papers do not spontaneously organize themselves back into a perfect stack. This increase in disorder may be what gives time its apparent direction. As the universe evolves, the overall level of entropy gradually rises. This creates a natural flow from past to future, where the future tends to contain more possible arrangements than the past. But this explanation raises another question. Why did the universe begin in such a low entropy state in the first place? The early universe appears to have been extremely smooth and ordered. That initial condition allowed entropy to increase over billions of years, producing the arrow of time we experience today. Yet scientists still do not fully understand why the universe began with such special conditions. Some researchers believe the answer may be connected to the earliest moments after the Big Bang, when the structure of space-time itself was still forming. Others suspect that deeper laws of physics may eventually explain why the universe started in such a remarkably ordered state. For now, the origin of time's arrow remains one of the most intriguing mysteries in physics. Time continues to flow forward, carrying galaxies across the cosmos and guiding the evolution of stars, planets, and life. And within that steady passage of time, something extraordinary happened on a small blue planet. A species emerged that not only experienced time, but began measuring it, studying it, and wondering about its meaning. And that curiosity itself may be one of the most fascinating mysteries of all.
Human curiosity is one of the most remarkable features of our species. From the earliest days of our history, people have looked at the world around them and asked questions. Why does the sun rise each morning? What causes storms to appear in the sky? Why do the stars move slowly across the night? Long before telescopes and laboratories existed, humans were already trying to understand the patterns of nature. This curiosity eventually gave rise to science. Through careful observation and experimentation, people began discovering the laws that govern the natural world. Over centuries, knowledge slowly accumulated. The motion of planets was explained, electricity was understood, and the structure of atoms was revealed. Yet, the more scientists learn about the universe, the clearer it becomes that knowledge often leads to new questions rather than final answers. Each discovery opens another door.
For example, when astronomers first realized that galaxies existed beyond the Milky Way, it dramatically expanded our understanding of the universe. But that discovery also led to deeper questions about how galaxies form and evolve. When physicists discovered quantum mechanics, they gained a powerful tool for describing the behavior of particles. At the same time, they encountered new puzzles about the meaning of probability, observation, and reality itself. Science, in this sense, is not a journey toward a final point where everything is solved. Instead, it is a continuous exploration. Every generation of researchers inherits the knowledge of the previous one and then pushes a little farther into the unknown. Sometimes answers arrive quickly. Other times, questions remain open for centuries. What makes this process extraordinary is that curiosity itself appears to be deeply connected to human consciousness. Our brains are not satisfied with simply observing the world. We feel a natural desire to understand it. This urge to ask questions has driven exploration across oceans, into the depths of the Earth, and far beyond our planet into space. Curiosity has built telescopes that can see galaxies billions of light years away, and microscopes that can observe structures smaller than a cell. Yet, despite all these achievements, the universe continues to reveal its complexity. Dark matter remains invisible. Dark energy continues to accelerate the expansion of space. The origins of life and consciousness are still being investigated. These mysteries do not mean science has failed. On the contrary, they show that the universe is vast enough to keep surprising us. Every unanswered question becomes an invitation to explore further. And perhaps that is one of the most comforting ideas in all of science. The universe is not finished revealing itself. There will always be more to discover, more to understand, and more to wonder about. As long as curious minds continue asking questions, the quiet journey of discovery will continue. And somewhere in the stillness of the night, under a sky filled with distant stars, that journey goes on, carried forward by the simple human desire to know what lies beyond the next mystery.
If you pause for a moment and imagine the entire history of the universe, it stretches across an almost unimaginable span of time. Billions of years passed before the first stars formed. Galaxies slowly assembled from clouds of gas and dark matter. Stars lived their long lives, creating heavier elements in their cores before scattering them across space. From those ancient elements, planets eventually formed. On one small planet orbiting an ordinary star, oceans appeared. Within those oceans, simple molecules slowly organized into the first living systems. Over countless generations, life evolved into an astonishing diversity of organisms. Plants spread across the land. Animals developed eyes, limbs, and complex nervous systems. Eventually, one species began asking questions about the world around it. Humans appeared. From a cosmic perspective, human existence occupies only a very small moment in time. If the entire age of the universe were compressed into a single year, human civilization would appear only during the final seconds before midnight on the last day. And yet, during that brief moment, something extraordinary happened. a species developed the ability to observe the universe and reflect upon its own existence. Humans began studying the stars, measuring the motion of planets, and exploring the laws of nature. Telescopes revealed distant galaxies. Spacecraft traveled to other worlds. Instruments built on Earth detected signals from events occurring billions of light years away. Through science, humanity has slowly pieced together a remarkable story about the cosmos. We have learned that the atoms in our bodies were forged inside ancient stars. The carbon in our cells, the oxygen we breathe, the iron in our blood, all were created long before our planet existed. In a very real sense, we are made from stardust. This realization connects human life to the vast history of the universe itself. Every living person carries within them atoms that once traveled through interstellar space. Yet, despite everything we have learned, many questions remain unanswered. What is the true nature of dark matter and dark energy? How did life first emerge from non-living chemistry? Why does consciousness exist at all? These mysteries remind us that our understanding of the universe is still incomplete. But that incompleteness is not a weakness. It is what keeps the search alive. Each unanswered question invites new ideas, new experiments, and new discoveries. Perhaps future generations will solve mysteries that today seem impossible to explain. New technologies may allow scientists to explore deeper into space, study the smallest structures of matter, or even understand the origins of consciousness. For now, the universe remains both familiar and mysterious. It is the place where we live, yet it is also far larger and stranger than our current knowledge can fully describe. And as our quiet journey through these mysteries begins to slow, one final thought remains. A reminder that wonder itself may be one of the most beautiful parts of being human.
As our quiet exploration of these mysteries comes to its gentle end, it is worth pausing for a moment to consider just how extraordinary the universe truly is. Every night, above the quiet landscapes of Earth, stars continue shining across distances so vast that the light reaching our eyes may have begun its journey long before human civilization existed. Some of those stars have already lived their entire lives and disappeared, yet their light is only now arriving here, crossing the immense darkness of space. In a sense, when we look at the night sky, we are also looking back through time. The universe is constantly unfolding, changing in ways both subtle and dramatic. New stars are born within clouds of gas drifting through galaxies. Old stars collapse into neutron stars or black holes. Entire galaxies slowly merge with one another over millions of years. These processes have been happening for billions of years, long before humans began observing them. And yet, within this enormous cosmic story, something unique has appeared. Life. On one small world orbiting a quiet star, molecules assembled themselves into systems capable of growth, adaptation, and awareness. Over immense spans of time, those living systems evolved into creatures that could observe their surroundings, communicate ideas, and wonder about the universe itself. That curiosity led to telescopes, spacecraft, and scientific theories that have revealed so much about the cosmos. But the deeper we explore, the clearer it becomes that the universe still holds countless secrets. Dark matter continues shaping galaxies from the shadows. Dark energy silently pushes space to expand faster with time. Quantum particles behave in ways that challenge our intuition. The origin of life, the nature of consciousness, and the true structure of space itself remain open questions. These mysteries remind us that knowledge is not a destination, but a journey. Each generation of curious minds steps a little farther into the unknown, building on the discoveries of those who came before. Perhaps centuries from now, scientists will look back at our current understanding the way we looked back at early attempts to understand the stars. What seems mysterious today may eventually become clear, and yet new mysteries will always appear beyond the horizon of knowledge. That endless unfolding is part of what makes the universe so beautiful. There will always be new galaxies to observe, new particles to study, and new questions waiting quietly in the darkness. For tonight, though, there is no need to search for answers. The mysteries can rest. Let your thoughts slow down like waves fading along a calm shore. Let the quiet rhythm of the night settle gently around you. The universe will continue its silent story whether we are awake or asleep. And somewhere within that vast and peaceful cosmos, you are here, a small but remarkable part of it. Now it may be time to rest.